Welcome, space explorers and curious minds, to a cosmic mystery that's captivated scientists for decades: the tragic transformation of Mars. Once, billions of years ago, Mars wasn't the red, dusty desert we know today. Imagine a young Mars, vibrant with flowing rivers, lakes of liquid water, and an atmosphere that hinted at the possibility of life itself. But something profound happened that turned this once promising world into the frozen, barren wasteland we see today. Join me as we embark on a journey through time, piecing together the clues scattered across the Martian surface and hidden within its thin, dusty atmosphere. Let's rewind the cosmic clock, about 4.5 billion years, to a time when the solar system was still in its rambunctious youth. The planets were just beginning to take shape, and the cosmic environment was a chaotic dance of celestial bodies. Planets were forming, asteroids were playing cosmic billiards, and Mars was a very different place. It was a world in the making, with its own unique story unfolding. Picture this: volcanoes erupting with fiery fury, spewing molten rock and gases that helped form an early Martian atmosphere. These volcanic activities were not just spectacular, but also crucial in shaping the planet's future. This wasn't just any atmosphere, it was thicker than what Mars has today, a cozy blanket that trapped heat and allowed liquid water to exist on the surface. This thick atmosphere was essential for maintaining the planet's warmth, and there was water, lots of it. Rivers carving channels through the Martian landscape, lakes pooling in craters, maybe even a vast ocean covering the northern hemisphere. This abundance of water was a key ingredient for potential life. The evidence is etched into the very fabric of Mars' dry riverbeds, ancient lake beds, and minerals that form only in the presence of liquid water. These geological features tell a story of a wetter, more dynamic past. It's a tantalizing glimpse of a lost world, one that might have even harbored the first stirrings of Martian life. The possibility of life on Mars has always intrigued scientists and dreamers alike. What kept all that water from simply boiling away into space? Early Mars had a secret weapon, a global magnetic field. This magnetic field was vital in protecting the planet's atmosphere. Think of it as a planetary force field, generated by the churning molten iron in its core. This internal dynamo was the source of Mars's magnetic shield. This magnetic field acted like a shield, deflecting the onslaught of charged particles constantly streaming from the sun, the solar wind. Without it, Mars would have been stripped of its atmosphere much earlier. It was a time of planetary promise, a time when Mars, like its neighbor Earth, seemed destined for greatness. Both planets had the potential to develop life and complex ecosystems. But as we all know, even the most epic stories have their plot twists. Mars's journey took a dramatic turn, leading to the cold, arid world we see today. Here's where things take a turn for the worse, my friends. About 4.1 billion years ago, disaster struck. The once robust magnetic field of Mars began to falter and fade. How can a planet just lose its magnetic field? Well, it's all about the core, that molten iron heart beating deep inside a planet. Earth's core is still active, constantly churning and generating that magnetic field we rely on. But Mars, being smaller than Earth, cooled down much faster. It's like the difference between a large pot of soup and a small cup. The cup will cool down much faster. As Mars's core cooled, its internal dynamo, the engine driving that magnetic field, sputtered and died. And with it went the planet's protective shield, leaving its atmosphere vulnerable to the relentless onslaught of the solar wind. Without a magnetic field to deflect them, those charged particles from the sun, the solar wind, had a field day. They slammed into the Martian atmosphere, stripping it away, molecule by molecule, over millions of years. Imagine, if you will, a balloon slowly leaking air. You can almost hear the faint hiss as the air escapes. That's what was happening to the Martian atmosphere, but on a much grander, more cosmic scale. The thin veil of gases that once enveloped Mars was gradually being stripped away. Without the magnetic field to protect it, the solar wind had a free pass to wreak havoc. These charged particles from the sun were relentless. It's a process called sputtering, and trust me, it's not pretty. The solar wind bombards the atmosphere, causing atoms and molecules to be knocked away. Those high-energy particles from the sun, they're like tiny little wrecking balls. Each impact chips away at the Martian atmosphere. They slam into the atoms and molecules in the Martian atmosphere, transferring their energy and sending those atmospheric particles flying off into space. It's a chaotic dance of destruction. Over millions of years, this sputtering effect can strip away a planet's atmosphere bit by bit. It's a slow, relentless process. It's like a slow, agonizing leak, and for Mars, it was a death by 1,000 cuts. The planet's once thick atmosphere was reduced to a thin whisper. NASA's MAVEN spacecraft, a mission dedicated to studying the Martian atmosphere, has been collecting vital clues. It's been orbiting Mars since 2014. It's like a cosmic forensics team, analyzing the composition of what's left of the atmosphere and measuring the rate at which it's still escaping into space. The data is invaluable. The evidence is clear. Mars is still losing its atmosphere today, though at a much slower rate than in the past. The planet's atmospheric hemorrhage continues. So we've lost the magnetic field, the atmosphere is thinning, and things are about to get really, really dry on Mars. This dramatic shift set the stage for a planet-wide transformation. Liquid water, the lifeblood of our planet, is a bit of a Goldilocks. It needs just the right conditions to exist. On Earth, these conditions are just perfect, allowing rivers, lakes, and oceans to thrive. And one of those conditions is atmospheric pressure, which plays a crucial role in maintaining liquid water. On Earth, we have a nice thick atmosphere that creates pressure like a heavy blanket keeping everything cozy. This atmospheric pressure is essential for keeping water in its liquid form. This pressure helps keep water in a liquid state, allowing it to flow freely and support life. But as the Martian atmosphere thinned, the pressure dropped dramatically. This drastic change had severe consequences for the planet's water. It's like taking that heavy blanket off. Suddenly, liquid water becomes much less stable. Without sufficient pressure, water couldn't remain in its liquid state. With lower pressure, water on the surface of Mars had two options, neither of them good for a budding planet. It could either freeze, locking itself away as ice beneath the surface, or it could sublimate, going directly from a solid ice to a gas water vapor, and escaping into space. It could either freeze, locking itself away as ice beneath the surface, or it could sublimate, going directly from a solid ice to a gas water vapor, and escaping into space. This process left Mars dry and barren. The evidence for this watery demise is written all over Mars. The planet's surface tells a story of a once wet world. We see dry riverbeds that were once carved by flowing water, now bone dry. These ancient channels are silent witnesses to Mars's watery past. We find hydrated minerals, chemical fingerprints that tell us liquid water was once present. These minerals are crucial clues, helping scientists piece together the history of water on Mars. Now, with the atmosphere thinning and water disappearing, Mars was locked on a one-way path to becoming the desolate world we know today. But the planet wasn't going down without a fight. The loss of its magnetic field had a domino effect, leading to a dramatic slowdown in volcanic activity. Volcanoes are kind of like planetary pressure valves, releasing internal heat and gases. But with the core cooling and the magnetic field gone, Mars lost its internal furnace. Volcanoes that once erupted with fiery might fell silent, their majestic peaks now just dormant giants on a dying world. This had a profound impact on the Martian climate. Volcanic eruptions release greenhouse gases which help trap heat and warm the planet. Without them, Mars grew colder, its grip on its already dwindling atmosphere weakening even further. And if that wasn't enough, tectonic activity, the geological dance of continents moving and colliding, ground to a halt. Mars became geologically dead, its internal engine sputtering its last. So you might be thinking, Neil, this is also depressing. Is there any hope for Mars? Well, don't despair, my friends, because even in the face of cosmic adversity, there's always hope. And in this case, it comes in the form of a spacecraft named Hope. The United Arab Emirates Hope probe, launched in 2020, is more than just a technological marvel. It's a symbol of human curiosity and our enduring fascination with the red planet. While previous missions have focused on studying the Martian surface, Hope is taking a different approach. It's orbiting Mars from a distance like a cosmic weather satellite, giving us an unprecedented global view of the Martian atmosphere. Hope is on a mission to understand the Martian weather, mapping out its atmospheric circulation patterns and how they change over time. By studying the intricate dance of atmospheric gases, Hope is helping us connect the dots between the loss of Mars's atmosphere and its impact on the planet's surface. Now I know what you're thinking, wouldn't it be amazing if we could somehow turn back the clock, reawaken Mars and restore it to its former glory? The idea of terraforming Mars, of transforming it into a second home for humanity, has captured imaginations for decades. But here's the cold, hard truth, it's not going to be easy. Remember all those things that went wrong for Mars? The loss of its magnetic field, the atmospheric stripping, the vanishing water? Those are some pretty major hurdles to overcome. Without a magnetic field, any new atmosphere we create on Mars would suffer the same fate as the old one, stripped away by the solar wind. And without a thick atmosphere, liquid water would be unstable on the surface. There are ideas for creating artificial magnetic fields, perhaps using a network of satellites, and for releasing trapped greenhouse gases to warm the planet. But these are massive undertakings requiring technological advancements that are still decades if not centuries away. As we conclude our journey through the Martian past, one thing is abundantly clear. Mars is a stark reminder of the fragility of planets and the delicate balance that allows life to flourish. By studying the red planet's tragic transformation, we gain a deeper appreciation for the preciousness of our own planet and the importance of protecting it from a similar fate. But Mars is more than just a cautionary tale. It's a beacon of scientific curiosity, a challenge to push the boundaries of our knowledge and explore the universe's most enduring mysteries. Every mission, every discovery brings us closer to understanding how planets form, evolve, and in some cases, meet their demise. Don't forget to like, subscribe, and hit the bell icon for more fascinating space explorations.